In this section, we will discuss using Microsoft Excel in order to conduct simple linear regression analysis. The least squared regression method provides an equation which gives the best linear relationship that exists between your dependent and independent variables. Sometimes, however, the best relationship is not sufficient or reliable enough for estimation. If you are estimating inventory or capacity or other major business decisions, it may be very costly if your estimates are inaccurate. Microsoft Excel gives various measures for determining whether a regression line is good or reliable. A quick Google search on regression analysis in Excel will produce a variety of tutorials to assist you with performing regression analysis in Microsoft Excel. Make sure that you indicate your version of Excel when searching for tutorials. After you have reviewed a tutorial on entering Microsoft Excel linear regression equation data, you should take our data from example 3 and enter it into Excel. Conduct a regression analysis, and your output should look as shown on this slide. The first thing that we want to discuss when reviewing our output for regression analysis is how to identify our regression line from the output. Next to intercept, towards the bottom of the output, they provide the B0 value for your data. For this problem, negative 25.6512 is our B0 value. Below our intercept is our slope, and it's right next to your independent variable. Our slope, or B1 value, for this problem is 0.5145. I should note that when I entered my original data into Excel, I included the column headings and selected labels in order to let Excel know that I included labels in my data. Using our B0 and our B1 values, we can construct our least squared regression equation as y hat equals our B0 value plus our B1 value times x. For our problem specifically, our y value was the shoe size, so we can predict the shoe size as negative 25.65 plus 0.515 times our independent variable, which was height. Next, we're going to discuss measures for evaluating a regression line in Excel. Excel provides the following measures for determining how reliable or good a line is for estimation. The coefficient of determination, also called R squared, the correlation coefficient, called R, and hypothesis tests for a significant relationship. First, the coefficient of determination. The coefficient of determination gives a value between 0 and 1. R squared technically provides the proportion of the total variation in y that is explained by the simple linear relationship between your x and your y variables. The closer this value is to 1, the more reliable the regression line is for estimating y. Therefore, we often say that the coefficient of determination helps us to determine how reliable this line is if we actually used it in order to estimate our dependent variable. For our problem, our R-squared value is located up top, and the value is 0.61332. Therefore, this line would be roughly 61.33% reliable if we used it to estimate our y value for this problem. The stakeholders at your business would have to determine what the cutoff is for what's considered acceptable in order for them to use the regression equation in order to estimate for that business. The correlation coefficient. This is a measure that we often hear about in research. For example, some of you may have heard about the past study that was conducted and reported, which showed a correlation between drinking red wine and having a healthy heart. It is very important for us to understand the correlation coefficient so that when we hear studies like this, we can ask more questions in order to investigate the true relationship between the variables. The correlation coefficient gives a value between -1 and +1. The correlation coefficient value is equal to the sine of your slope, which is b1, times the square root of the coefficient of determination. The closer your correlation value is to 1 or -1, the stronger the relationship is between your independent and dependent variables. The closer this value is to 0, the weaker the linear relationship is between our variables. In Excel, multiple R is our correlation coefficient. Here, our multiple R value, for example 3, is 0.783155. This value is relatively close to 1. At least it's closer to 1 than it is to 0. So we can say that there is a pretty good relationship or linear relationship between our variables. For our example with drinking red wine and having a healthy heart, you should always ask what your correlation coefficient value is. Often in research, they will report correlations even when your correlation value is as low as 0.2. For a correlation value of 0.2, the relationship between our variables is indeed weaker than it is for the data that we explored in this problem. We should note that Microsoft Excel does not provide negative values for our correlation coefficient. Therefore, you should interpret your correlation coefficient value and make that value negative if your slope or B1 is negative. The last measure that we're going to discuss in Excel is the t-test for testing for significance for your regression analysis. The t-test for regression tests the hypotheses listed on this slide. The null hypothesis is always that beta 1 is equal to 0, or there is no relationship between your independent and dependent variables. Your alternative hypothesis is always there is a relationship between your independent and your dependent variables. For all hypothesis tests, computer programs such as Microsoft Excel often produce a p-value which takes into account the actual null hypothesis for your test. By computing this p-value, there is one universal rejection rule that you can apply. That rejection rule is reject H0 if p is less than some specified alpha or level of significance. In Microsoft Excel, your independent variable will have a p-value for this t-test. Going back to our spreadsheet in the same row as our independent variable, we have the p-value. And in this case, our p-value is 0.007377. So if we had specified a level of significance or alpha value of 0.05 for this problem, our rejection rule is reject H0 if p is less than alpha. So if our p-value is less than 0.05, we can reject the null hypothesis in this case and conclude that we have found sufficient evidence to prove that our alternative is true. A p-value of 0.007 is indeed less than an alpha value of 0.05. Therefore, for this case, we can reject H0. Recall from our hypothesis testing chapter, rejecting H0 means that we have found significant evidence to prove that there is indeed a linear relationship between our independent and our dependent variable. Now let's get some hands-on practice with analyzing a regression analysis output in Excel. Recall our data provided on the slide from example 5. First, let's write the regression equation for this data. Second, let's identify and interpret the coefficient of determination. Third, let's identify and interpret the correlation coefficient for this problem. You should pause the video at this time and try to complete this problem. You should have entered your data into Microsoft Excel and conducted a regression analysis. Your output should look as shown on this slide. Our B0 or intercept value is equal to 10 and our B1 or slope is equal to 5. Therefore, your regression equation should be Y, which is cars sold, equals B0, which is 10 for this problem, plus B1 times X. For this problem, it's the number of ads. Second, our coefficient of determination, or R-squared value, is 0.877. Therefore, we can conclude that our line would be approximately 88% accurate if we used it to estimate the number of cars sold based upon the number of ads that were run the prior weekend. Our correlation coefficient is 0.936586. Since our slope is positive and this value is very close to 1, We would say that there is a very strong positive linear relationship that exists between the number of cars sold and the number of ads that were run the preceding weekend for this problem.